This is the walkthrough for the Cyber Threat 2023 Hackable badges. So when we first enter the challenges, we'll find ourselves in a little room. And if we look around, we're stuck in this room. There is a computer. If we try entering it, it's asking for 4 digits. We could try guessing them, but there is a better way. If we interact with some of the other things in the room, we'll notice that one of them here, we've got some letters, got a U, D, L, and D. And if we go and try UDLD, we get the door open. So next challenge is over here. So we've got a room, we've got kind of 3 computers in here. There's another one there. Then up here we have another 2. We just ran past one there. So if we have a look at these ones first, we've got some weird symbols on the left, some weird symbols on the right. And if we have a look at some more of them, have a look at this one, we've got different weird symbols and some on the right. And let's just go have a look at the last one. It's the same deal. So these symbols on the right are Mayan numerals, and there's a little hint for this. If we look in the file browser, challenges, documents, see there's got extracts from Wikipedia. So this one's a hint for this challenge. And we've also got here this one about multiplication. We'll see that one very shortly. So if we look at this, these on the right are Mayan numerals, where the horizontal lines are 5s and the dots are 1s. So this would be 5, 5, 4, which gives us 14. So if we, let's start with this one. These symbols don't actually mean anything, they're just arbitrary symbols, and these little dots are multiplication. So if we read this as an equation, we get x plus 2y minus z equals 6. And if we try reading one of the other ones, let's have a look at this one, we get 2z minus 4y equals 14. So just to be clear, the x, y, z, it doesn't really matter what, it's just to make it easier to pronounce these nonsense symbols. And so here we'd get 4x minus 2z equals 10. And we've now got 3 equations. These form a system of linear equations or simultaneous equations. We could solve them by hand on a napkin, or we can just go paste them into Wolfram Alpha and it will give us the solution. So if we head to this terminal here, it's going to ask us for the solution. We get 13, and then the next one's 7, last one is 21. There we go, 21. So we've done that challenge. The next one is this challenge. It's got some blinking lights, and I will just grab off to the side some little wires. These are going to come in useful, because what we can see is we've got a 1, 2, a 3, and a 4. Those line up with the LED pins on the side. And then we've got this kind of diagram. If we imagine this wire connected, we've got from 1 to 2, from 3 to 4. So if I just put a little bit of wire from LED 1 to LED 2, we can see that now this 3 has started blinking. And if I just try and hold that in place while I get the other wire in, from 3 to 4, you can now see they're all blinking and it's fixed to the picture. So that's that challenge done. But now, if we try and leave this room, we're stuck. And during the event, many people thought this was a bug, but it's not, it's actually the challenge. So if we look at this terminal here, it mentions capacitors. And if we think, how could we discharge capacitors? What if we turn the badge off? Sure enough, the door's open. And if we just wait a moment just to confirm, we'll see that, yep, and it shut the door again. So the next challenge is over this way. It's up here. So we've got these 4 computers and then one more here. If we have a look at this one, it's asking for an 8-digit code. We can try just doing random. It won't work. And you're not going to be able to guess an 8-digit code unless you're really, really patient. So let's have a look at these terminals instead. What have we got? We've got a smashed QR code, a smashed QR code, smashed QR code, and here's a real QR code. So during the event, everyone had a different one of the 4 QR codes that they could use. So the intent was to try and get people to talk to each other. But if we want to solve this after the event, there's only one badge that you've got. So if we restart the badge, what we'll notice is that it randomly assigns which one you get. So here you see this one's smashed now. So if we have a look at the others, that one's smashed. So we got this one instead. And if we restart the badge another time, we will probably get a different one. Obviously it's random, so we might not. Which one did we get? Yeah, we got that one. So actually, we might as well just restart it to get the last one, just for completeness sake. Okay, here we go. We got the last one. There we go. So it took way too long to get that one, but I mean, that's just the nature of randomness. So if we scan all 4 codes, we're going to get some base 64 strings, which we have right here. So we're looking at them, we can tell they're base 64, or at least probably base 64, because we've got these equals and these pluses. They're kind of, it looks classically base 64. So if we go drop it into CyberChef, this is a really useful tool. We can ask for from base 64. We've got this kind of output here. It's all merged them together. So if we just put a fork at the start, now it's doing them all individually. What we can see is we've got this little XOR here. This is a hint as to what we need to do. But for now, let's just put them to hex to make it easier to work with. And let's just remove the spaces so it gets on one screen. So now we've got these. We can just switch over to a new CyberChef, paste them in. We just put them into hex to make it easier to copy around. So knowing that there was that little XOR hint, if I just drag in, let's go 3 XORs. And if we just XOR them all together, there we go. The answer is up, down, left, right, left, up. And if we switch back to the badge, let's give that a try. So it was up, down, left, right, left, up. There we go. So the next challenge is going to be over here. See, these doors have opened. They weren't open earlier. And in this room, we've got a bunch of computers, 3 to be precise, and each one has a different selection of numbers on it. So let's just have a look at this one first. We've got a 1, 2, 5, 6. Let's have a look at number 2. It's a bit flickery on the camera, but what we've got is this actually lines up here, and these blinking squares, they're lining up with the resistors there. So in this case, it's blinking the one, just one from the right. And if we actually read off the board, that would be C17. So we know that 2 is C17. If we look at 1, what have we got there? That lines up with that component. Which one's blinking? It's that one, which would be U3. Let's have a look at 5 while we're here. This lines up with there, so that blinking component would be C3. For 6, this one is that component. Is it? No, it's that component, which is R17. So that's lining up. There's some under the cable. So if we look at some of the others, so there we go. So this one is under the cable. So if we kind of remember what it looks like, we've got this square, 2 things, then 1 blinking. We can actually just disconnect the screen. And there we go. So the one that was blinking was down in there. It's R11. And let's just put the screen back on so we can actually see what we're doing. There we go. We probably need to turn it off and on again. So if we do that for all 8, what we will get is U3, C17, R11, C11, C3, R17, C20, and R3. And that's quite a few, well, it's 8, but they're all over the place. But if we actually just look at the numbers, we've got 3, 17, 11, and 20. There's only 4 different numbers there. You know, what do we have 4 of? We've got 4 of these. And if we actually map that to the alphabet, let's say if we start the alphabet at 0, so A to 0, B to 1, what would 3 be? Well, that's a D. That's looking about right for down. So if we head over to terminal all the way at the end, then we just think about that code. So we've got up, right, left, down, left, up, down. There we go. We got it. So the next challenge is actually at this terminal again. Here we go. So this is really not coming across in the camera, but we've got some squiggly lines. And if we turn these dials, it's changing the way they look. And what we'll notice is that there's a kind of optimal position that we can put them in that will make the lines the least squiggly. We're trying to make them look like perfect sine waves. So here, we're almost there, so it's saying that we're close. What we can see is that 1, 2, 3, 4. So we've got 4 taps of close there. So if we kind of put it roughly in the middle, how many? Oh, there we go. We just got it. There we go. So that one's not too bad, but this next one, unfortunately, is. So if we go all the way up, in this challenge, we've got to kind of fly around and pick up all of these. I think the flavor text says asteroids, but they could be whatever. The challenge is, though, that once you've visited a spot, you can't visit it again. And it's really easy to get yourself in a position where you're just going to fly right off the edge. So there's a few ways to solve these. You can just do it by hand. That is a very viable solution. Alternatively, if you write a little script, you can actually quite easily spit out every single possible solution because it's a small enough puzzle to solve it. So here's a solution that you can follow along with up, right, down, right, up, left, down, right, up, down, left, up, left, down, right, up, right, down, down. If I recall correctly, there are 75 possible solutions. So that's a really interesting one there. You can solve it with a script. If you do a breadth first search, then you'll find all possible solutions, and it should only take a few seconds to run. So the next challenge is here. We've got a computer that's asking for an MFA code. Now, this is interesting. We don't have a code that we can enter. If we try random stuff, it'll just tell us it's invalid. Something to bear in mind, though, here is system time is 1st of January 1970. So you should be able to recognize this. That's the Unix epoch, which basically means the time is set to 0. So if we have a look elsewhere on the badge, let's go to the file browser, our favorite, and in challenges, we've got this interesting file, 2fa.min.js, which we can assume probably goes along with this HTML file. But if we click on them, well, in this case it crashed. Okay, so the issue there was, as ever, that my batteries had run flat, so I just grabbed a new pair of batteries. So we've got these 2 files. If we click on them, it's going to say that it's transmitting the file. So it's interesting, we can't view it on the badge, but if we have a look, there's a file here, transfer.txt. It tells us how to receive files from the badge. So there's a few different ways we can actually receive the files. The fancy way would be to write a script to do it for us, but we don't actually need to do that because the files that we need to receive are just plain text. We've got JavaScript and HTML. So if we've got any serial console, we can do it. I'm going to use the Arduino serial console just because it's really easy to use. I've connected with the appropriate baud rate, and now if I select 2fa.min.js, there we go. So here's one file. We can copy this out, and if I just clear the output and then instead select index.min.html, there we go. There's the other file. So we're going to want to copy these both out into a text file, which we can then run. So once we've loaded that HTML file, we get this thing showing, and what we've got, big red button. So let's click the button and let's select the badge. And what we will notice is that on the badge, it's now generating codes. These sound promising, but this number down here that's going up by 1, that's the current time. We need to set that to 0. So if we have a look back in the code, let's go inspect sources. Now here we can look at the JavaScript, and there's quite a lot going on here, but what we can look down is we've got these kind of i.write calls. In this case it's r.write, but that's just because we're looking at minified code. So in this case it's just writing constant data, and we can see wake up to FA. This is probably not what we're concerned with, but down here what we can see is it's giving it the date. If we set a breakpoint here, then we connect, what we will notice is nothing happens initially. We just paused. And if we look down at the badge, it's just saying wait. So in our code, if we look at I, that's the current time. So what if we set I equals 0? That seems promising. So I'm going to click this blue button. I'm just going to make sure you can see what happens on the badge. So there we go. We'll notice down here, almost there. So we just need to be a bit faster, because in that case we took about 20 seconds to do that. So if I just refresh the page and I connect, as soon as we get that wait, let's just go I equals 0 and resume. There we go, we caught it just in time, 481748. We just need to enter the code now. So if we go 481748, there we go. So the final challenge in this game section is going to be all the way back near where we started, which is down here. We've got a new room. And if we look at this little terminal, collecting samples, interesting. So again, this is another one where if we have a look in, this has got an old version of the SD card. So there is a file that talks about samples, and it has a little picture. It's an ASCII art of the SD card. So if I just look, see it says 1 out of 4. If I turn off my badge and I grab a different SD card, I've got a handful here. Let's just try this one. I turn it on. Ooh, 2 out of 4. So let's, again, another SD card. Turn it on. Three out of 4. And let's just grab a 4th SD card. And this should be the final one. Hey. So, something you might have noticed is this needed 4 SD cards, which is very easy when you're at the event, not so easy when you're at home. So we did program in, if you do A, B, A, up, down, down, left, right, 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 B, A. So if you just key that in, then you go into settings. There's now this extra menu here, internal. And just down here, you've got an option, randomize SD card. When you click this, nothing particularly pretty will happen. But what that did is it made the badge think it got a new SD card. So if you click here, it will register it as a new card. You can also do it if you plug your SD card into a computer and you open it in a hex editor. You can attempt to identify where it's storing that random number, and you can alter that, which is the much harder way to do it, but if you don't want to do it with the secret cheat code. And this got us to the final room, where it just tells us to connect over serial for the serial challenges. And those are the much more technical challenges. So those are all of the challenges in the game on the badge. And if I just exit out, There we go.